Good morning, friends. Uh, Welcome to this video session. In this video lesson, today we are talking about NC machines. NC machines means numerical control machines. So, how these numerical control machines have evolved, and what are the various components of this machine, how they look like, and what are the functions of each component. All these things we will deal with this session. Okay, so to start with these numerical control machines, first of all, let us go back to the manufacturing processes. So in olden days, that is pre-industrial revolution era, so the goods that were manufactured by human beings with their own hands mostly, are by using a small instruments or small tools. So whatever the goods that let it be a vessel, let it be anything, a bullock cart or any agriculture implements, and all these things were used to manufacture by human beings with small tools and the materials that are available to them. So this was there for so many years till the arrival of new machines. So till the industrial revolution that was occurred in 1760 to 1820 in Great Britain and other parts of the countries. So this industrial revolution has changed the course of human beings. So therefore, the industrial revolution was the transition to new manufacturing process in Europe and the United States in the period from about 1760 to somewhat between 1820 and 1840. That means this transition includes, why we are saying that this is a transition, this transition includes what happened, including going from hand production method to machines, new chemical manufacturing and iron product processing, the increased use of steam power, the water power, and the development of machine tools, and the rise of mechanized factory system. So this industrial revolution has also led an unprecedented rise in the rate of population growth. So what happened during this industrialism? Because the invention of steam engine, the invention of cotton gin, the invention of spinning jenny, and all these things paved the way for the production of new machines. And these machines helped has changed the manufacturing process from hand production to mechanized production. Therefore, the industrial revolution marks a major turning point in the history. Almost every aspect of daily life was influenced in some way. In particular, average income and population began to exhibit unprecedented sustained growth. Some economists say that the major effect of the industrial revolution was the standard of living for the general population in Western world to begin with, and for the entire world history. Therefore, that means the change in manufacturing process, the introduction of new machines really paved the way for these type of these things. So this is what. So during the industrial revolution, the new machines have been introduced. Though the new machines were introduced, still the manufacturing used to be done by the 3 M's. That means to make goods or services, we need three things, the 3 M's. First is material, that is raw material. Second one is machinery, that is the machines which will convert these raw materials into finished products. Third one is manpower, that is human power. So the labor. These 3 things are necessary. So till 1940s, so we have these concepts. That means machines were still need a help of human beings. Therefore, this is what we call as the traditional manufacturing system. So now we will discuss from traditional manufacturing to how these new manufacturing, the process of new manufacturing system, that is advent of numerical control and all these things come. Let us see. So now I'll give an introduction to NC machines. So I have prepared a PPT for this. Based on this, we will try to make a note on these NC machines. I'm sharing the screen here. Okay, here we go. So numerical control machines. So I am Anand Padavala. I am a senior faculty member in the Department of Technical Education, Government of Telangana. So let us go with the introduction part to the NC machines. So in conventional machines, parameters like feed, depth of cut, and speed are manually controlled by operators. And the accuracy of the job is essentially on the skill of the workers. This is the conventional machining or a traditional machining. If at all we want to manufacture anything here, so what we have to do is we have to give, that means human beings, the operator should give the feed, speed or depth of cut, all these things. So the accuracy of the job definitely depends essentially on the skill of the workers. This is what a traditional or conventional machining process in the manufacturing. But conventional machine have some disadvantages. We know it will take more time consumption because the operator has to do all these things. Accuracy is less. There will be ever possibility of human error. And because it is not done automatically and entire operation should be performed by the operator only, therefore less production, and it requires very skilled labor. If the skill is not there, then the accuracy and the quality of the production will be very less, and more wastage of material. The material wastage will be more. Therefore, that is also a disadvantage of the conventional machine. And how to overcome these disadvantages? That means something has to be done for reducing these lacunas in conventional machining. So these limitations were addressed to some extent with the advent of numerical control. So the advent of numerical control machines definitely is a result of the limitations of the conventional machine. So what is a numerical control? The name itself is a control. Control means it is controlling something. What is it controlling? Maybe it is controlling the manufacturing operations. Therefore, numerical control is the method of controlling the manufacturing operations through numerical instructions in the form of directly inserted codes in machine tools. That means numerical control means it is a method of controlling the manufacturing operations or machines. For example, earlier we used to give the feed, depth of cut and all these things, speeds, and now these will be controlled not by the operator but with some control. That control is in the form of numericals, in numerical instructions and directly inserted codes in machine tools. This is what a numerical control is. So therefore, hence, numerical control is not a machining method. It's not a new machining method. Rather, it is a concept of machine control. That means we are using the same machines only, but the control is not done by the human operator. Human operator will be there, but some control will be done with the help of these numericals. Therefore, that's why it is called a numerical control. Therefore, the numerical control, in a numerical control, a machine tool is operated by a series of coded instructions that includes numbers, letters of alphabet, the symbols that the machine control unit can read. That means in numerical control, what happens? The machine is operated by not by human being or operator, but it is controlled, it is operated by series of coded instructions. That means whatever the instruction we want to give to the tool. Earlier, the operator used to perform the operations. That means he himself is giving instruction. Not only instruction, he himself used to do with his own brain. Now, the machine will be given instructions in the form of letters of alphabet, numbers, or symbols, and that machine tool can understand these instructions with the help of a machine control unit called MCU. So these instructions are converted into electrical pulses that the machine's motors and controls flow to perform the manufacturing tasks on a workpiece. So when we have a workpiece here, what we will do, we will give instructions in the form of letter symbols, and these instructions are converted into electrical pulses, and these electrical pulses will be carried to the machines or with the help of motors or controls, and these manufacturing tasks on the workpiece will be performed. So numbers, letters, and symbols are coded instructions that apply to specific distances, positions, tasks, or speeds that machine tool can understand its machines as it machines the workpiece. When a machine tool is about to machine work the pieces, it can understand the instructions given in the form of numbers, letters, or symbols. That means a particular symbol may be indicated a feed rate, increase of feed rate. Particular symbol may indicate the change of position from X direction to Y direction. Some sort of instructions will be given where the machine can understand, machine tool can understand these instructions, coded instructions. So let us give a proper definition to numerical control. So definition of numerical control. Numerical control is defined as the form of programmable automation in which the process is controlled by the numbers, letters, and symbols. By the numbers, letters, and symbols. So numerical control is defined as the form of programmable automation in which the process, that the manufacturing process is controlled by when we talk about numerical control can be applicable not only to the machines, to any operations. So, but here we are discussing about numerical control machines. Numerical control is defined as the form of programmable automation in which the process is controlled by numbers, letters, and symbols. So in case of machine tools, this programmable automation is used for the operation of machines. So this is what we have. Now let us see the history of numerical control. So how the numerical controls have evolved, or evolution of numerical control. So the invention of numerical control has been due to the pioneering work of John T. Parsons in the year 1940, when he tried to generate a curve automatically by milling cutters by providing coordinate motions. This is the first step in numerical control. Till 1940, the machines were operated purely by human beings. That means whatever the feed, whatever the depth of cut, whatever the speeds that are supposed to be given to the either to the workpieces or to the machines, they used to give by operators only. No one was controlling other than human beings till 1940. But the first time a person named John T. Parsons, thanks to him for the invention of this numerical controls machine. So in 1940, he tried to generate a curve automatically by milling cutter. That means without his involvement. So he provided a coordinate motion so that the milling cutter will cut the curve automatically without the operator. So this is the first step in the invention of numerical control or the history of numerical control. So in late 1940s, Parsons conceived the method of using punched cards containing coordinate position system to control a machine. So with the help of punched cards, that means punched card means cardboard will be there, the punches will be there. So based on the number of holes or whatever they may be, he could make a method, that means coordinate positioning system can be changed with the help of these punched cards. So thereby controlling the machine. This is in late 1940s. The machine directed to move in small increments and generate a desired finish with the help of this one. And in year 1948, Parsons demonstrated this concept to the Air Force, who sponsored US in United States, who sponsored the series of projects at laboratories of the famous MIT, Massachusetts Institute of Technology. So in MIT, he has demonstrated the concept of this numerical control. After a lot of research in MIT, they could able to demonstrate first numerical control prototype in 1952. And in the next year, that is in 1953, they were able to provide a potential applications of NC systems. So they have made a portable numerical control operating system. So with the help of the pioneering work of Parsons. So this is what. And soon the mechanical machine tools, that is manufacturing, has begun their own efforts to introduce commercial numerical units in the markets, though for 1950 to 1952. Meanwhile, the research was continued at MIT and were able to discover automatically programmed tools like ATP language. That means how to program the tools. That means when a program is made, and if the tool can move according to that program, then this language, that means machine language. Machine language is very important. The invention that means APT, automatically programmed tool language, was used programming the NC machines. So this is a major step of innovation of numerical control. And the early mechanisms which were incorporated in NC were soon improved with both analog and digital computer after the arrival of computers, and these programming were given to the computers. So this include, with the help of computers, the introduction of computer technology into the concept of numerical control led what we know now as computer numerical control. So soon after the development of numerical control systems, introduction of this computer technology to the numerical control has made the way for one more new methodology in numerical control, that is computer numerical control, has evolved. So this is the history of numerical control. Now let us see basic components of a NC machine, that is numerical control machine. So what are the basic components of NC machine? So the basic components of NC machine are program of instructions, machine control unit, and machine tool or processing equipment or other controlled process. In case of manufacturing, we will call it as a machine tool, or any other process other than manufacturing, then we will call it a processing equipment or other controlled process or whatever. So basically, three important components of a machine tool: program of instructions, machine control unit, and machine tool. So this is what we have. These are the basic components. This is a program, that is program of instructions. These program of instructions may be in the form of tape, punched tapes, and these punched tapes are given to inserted in machine control unit, and this machine control unit can understand the program of instructions, and it will give directions or controls to the machine tool. So whatever the instructions are given here can understand and can instruct with the help of the servo motors or whatever the mechanisms they have. It will give the instructions to the machine. That means now the operator need not perform here. Whatever the program instructions are there, that will be given by the machine control unit to this one, and the program will be done automatically without intervention of the human. Of course, human intervention is necessary for fixing jigs or fixtures or whatever it may be. So to some extent, the real operations can be controlled with the help of machine control unit by reading the program of instructions. Now, so what do you mean by program of instructions? In program of instructions, so the program of instructions of a machine is step-by-step set of instructions that tells the machine what it has to be performed, what it has to do. That means program of instructions is nothing but a step-by-step. For example, I want to make a drill on a component or on a workpiece. So what is the first step? You have to fix a job onto the table, a drilling machine table. So that is the first step. Second step is what? So we have to use the drill bit, whatever the diameter of drilling is required. That fixing of the tool. Then point of location, that means where we have to drill, marking the point on the workpiece. Then you have to make a drill by using the by pressing the lever of the drilling, switching on after switching on the drilling machine. These are the step-by-step instructions. What the machine. So instead of giving a human brain instructions and doing those things, here these program of instructions will give the step-by-step instructions, set of instructions. So these instructions can tell the machine to turn the piece of metal to certain diameter, or drill the hole of certain diameter up to certain length, or form certain shape, form a certain shape. So whatever the instruction may be, it will be given. In case of a turning, certain diameter; in case of drilling, certain hole and certain length; and in case of any other shape, form shape, milling machines and all these things. And the set of instructions are coded. And how the set of instructions are given? The set of instructions are coded in numericals or in symbolic form and written on a certain medium that can be interpreted by the control unit of the instruction. So we can't write on a piece of paper that you have to take this diameter and like this, because this language can be understood by human beings. Our own English language can be understood by our human brain, but the machine cannot understand. So we have to write we have to give the set of instructions in some sort of codes with the help of numericals or symbols. But these codes can be the machine should be in a position to interpret these codes. So by the control unit of a NC machine. So this is very important. So the mediums commonly used earlier for writing the instructions were punched cards. So the medium of instructions were given in punched cards, magnetic tapes, and 35 mm motion picture film. But now 1 inch wide punched tape is used more common. So in the form of punched tapes or magnetic tapes. For example, in our tape recorder, the magnetic tape will be the tape. So that magnetic tape will, whatever the written in that magnet tape will be converted into audio. So similarly, so punched cards, magnetic tapes, and 35 mm motion films and all these things were used earlier. but now 1-inch wide punched tape is used most commonly. Now, the program of instructions are written by the experts who have programming knowledge as well as the machine language. So who should write these programs? So an expert is needed to write these programs, and he should have the knowledge in both. They should have a machining knowledge, that means what are the operations that are to be performed on the machine, as well as programming language. That means he should be in a position to write a program such that machine can understand that program. So he should know the machine language also, that is programming language. So he should be an expert, and he should have a knowledge of both programming as well as machining processes. So the person should know the various steps of the machining requirement to manufacture a particular product, and should be able to write these steps in the form of the program that can be understood by control unit of the NC machine, which would eventually direct the machine to perform the required machining operations. Therefore, the person should know the various steps of machining, and also he should write a program such that machine can understand whatever it is written, and as per the normal manufacturing process. So one can also input the instruction directly into the control unit manually. So as the developments are going on, earlier we used to have a punch tapes, but afterwards we can directly input the manual data input through the MDI, that is, and the control unit. So we have said 3 important things. One is a program of instruction, second is a machine control unit, third one is machine tool. In machine control unit, if we can directly insert the directions or the instructions, then the job will be very easy. We can eliminate the program of instructions separately. We can directly give on the control unit itself. So that is a latter development of NC machines. This is what we have now. This is the program of instructions. So basically, program of instructions is nothing but it is a step-by-step procedure given to the machine tool. What are the things what a machine should do? So these instructions are given in the form of letters, numbers, or some coded information, and these are prepared on a medium where like punched tapes or magnetic tapes or 35 mm motion movies or 1-inch tape, wide tape, and all these things are the program of instructions. One important thing is this program of instructions should be prepared by an expert who is having a knowledge of both machining as well as a programming language. So this is what the second important component or basic component is control unit, or we will call it as a machine control unit, MCU. In fact, this is a heart and brain of a NC machine. This is very, very, very important component. So the control unit is the most vital part of NC and CNC machines. Even in CNC also. In CNCs, this machine control unit will have a computer, mini computer which will be there. But in numerical control, it's a control unit only. So the controller unit or machine controller unit is a very vital part, heart and brain of a NC machine. The controller unit is made up of electronic components. So it consists of electronic components. It reads and interprets the program of instructions and convert them into mechanical action of the machine. So whatever the program of instructions are given to this machine control unit, so the machine control unit should read the program of instructions given to it, and it should also interpret the program of instructions. So it should be able to read, and it should interpret the program of instructions, and it should convert them into mechanical actions of the machine. That means, first of all, it should read the program of instruction, it should understand, and it should give directions in the form of mechanical actions to the machine tools. So what it has to be performed. So thus the controller unit forms an important link between program and machine tool. So the program is there and the machine tool is there. So in between it is a link. The link is called machine control. This is very important. Whatever the programs are there, it will understand the program, the step-by-step procedures, and these step by it will understand, not only understanding it, but it will give instructions to the machine tool and what the machine tool has to be done. So this is what we have. So the control unit operates the machine as per the set of instructions given to it. So the machine control unit will control the operations of the machine as per the set of instructions given to it. Now, a typical control unit comprises of, so in a controller unit or machine control unit, you have certain components, or you should have certain parts in it. One is tape reader, a data buffer, signal output channel to the machine tools, feedback channels from the machine tool, magnetic box, and the sequence control to coordinate the overall machining operations. These are the components that the machine control unit will have. So tape reader, that means it will read the set of instructions, and whatever it has read, it will be stored in the data buffer, and whatever it understood, it will give the instructions to the machine tools with the help of signal output channels, and it will take input from the feedback channel whether the machining tool is performing as per the instructions or not. And the magnetic box is it will receive the instructions from control unit, and it will give the instructions to the machine tools. Sometimes it will give direct instructions to the machine tools. That means switch off, switch on, spindle speed, and all these things directly can be given by magnetic box. And very importantly, the sequence control to the coordinates. That means whether it is going according to the sequence of operations or not, it will check. All these things will be there as in the machine control unit or controller. Now, initially, the set of instructions from the punch tape are read by the tape reader, which is sort of electromechanical device. That means the set of instructions are in the form of punch tapes, and these punch tape, whatever the information is there in the form of punch tapes, will be read by the tape reader. This tape reader is to read. So this tape reader is in the form of electromechanical device, so it can understand that. And the data from the tape is stored in the data buffer. Whatever it has read, it should be stored in the data buffer in the form of logical blocks of instructions. In the form of logical blocks of instruction, with each block resulting in certain sequence of operation. So whatever the data is received will be stored in the data form, data buffer, and this data buffer is stored in the form of logical blocks of instructions, and each block resulting in certain sequence of operations. Now, the controller, what happens, sends once, that means the tape reader has read the instructions of punched cards and it is stored in the buffer. Now it has know the instructions, and what the controller will give, the controller will send the instructions to machine fields via signal output channels. So the signal output channels are from control unit to the machine tool. So by reading the data and by storing the data in the data buffer, these control unit will send instructions to the machine tool through the signal output channels, which are connected to the servo motors and other control. How these channels are given? These channels are given in the form of servo motors. Therefore, the instruction is given, feed rate is 0.2 mm. So that servo motor will give a feed rate only 0.2. So it is moved, the tool is moved 0.2, or the spindle speed 1500 RPM. So once the instruction is given, the servo motor will help to make the spindle to rotate with a speed of 1500 RPM. So like that, all other control machines will be done. So the controller sends the instruction to the machine tool via signal output channels that are connected to the servo motor. Now, the feedback channels, what happens? The instructions are given. Now the machine has started functioning. Now we should see whether the machine is following the instructions given to them correctly or not. That means there should be a control. There should be a check whether the given instructions are, whether the machine is following the given instructions correctly or not. Therefore, the feedback channels ensures the instructions have been given, executed the machine correctly or not. So this is a very important thing. Next one. The sequence control part of the controller unit ensures that all the operations are executed in a proper sequence. So the proper sequence of operations in any manufacturing system, the sequence of operations are very important. So without fixing a tool, we can't go for a drilling, and without giving all primary operations, we can't go for assemblies. Therefore, the sequence of operations are very important. So the sequence control part of the controller unit ensures that all the operations are executed in proper sequence. And the magnetic box. The magnetic box receives electrical signal from control unit for all other activities. For any activity, magnetic box will receive the signals from the control, except for the servo motor drives. So except other activities, except for servo motor drives, and the spindle motor starting or stopping, selecting spindle speed, making tool changes, control the coolant supply. All these then can be directed from the magnetic box itself. So you need not go for from the control unit. Some of the instructions we can give the magnetic box, not all, not the real production, but the starting and stopping of spindles and all these things we can give from the magnetic box. So one important thing to note about the control unit here is that all the modern NC machines are equipped with the microcomputer. Now earlier we used to have a controller unit. Now in the modern NC machines, these control units we are equipped with microcomputer that acts as a control unit. So controller unit, the numerical control system has been updated with the help of a microcomputer. Therefore, such machines are now we are calling it as a computer controller machines or computer numerical control machines. And the third one is machine tool. The third basic component is machine tool. So it is a machine tool that performs the actual machining operation. So actual production, actual manufacturing will be done by the machine tool only. Earlier also, before advent of numerical control, only machine tool used to perform. Now also machine tool only performs. But this machine tool will be controlled by operator earlier in traditional machining. Now the machine tool is controlled by numerical control with the help of set of instructions and the machine control unit, and this will control. But the machining operation will be performed with the machine tool only, whether it is a traditional or an NC machine. So machine tool can be any machine like lathe machine or drilling machine or a milling machine, etc. Now, the machine tool is the controlled part of an NC system. The NC machine have the control panel and a control console that contains the dials, switches, using which operator runs the NC machine. So NC machine control panel will be there. So on the control panel, we can use the dials and we can use the switches so that we can operate the NC machines. So in case of CNCs, microcomputer operators machines as per the set of instructions of the program waves. So these are the components. So this is a block diagram of NC machine. This is the machine control unit. Program of instructions will be given machine control unit. And this machine control unit you have, so tape reader will be there that will read, and data buffer will be there. The data buffer will store the data, whatever it has read, and after storing that data, it will give instructions. So it will give instructions with the help of servo motors, and also it will take the feedback from the feedback channels, whether the machine is operating as per the instruction or not. And also we have a magnetic box. We can operate spindle speed and some direct operations without the program of instructions, that we can perform directly. So machine controller will be there. So this is the main components of machine, NC machine. Now, what are the advantages we have of NC machines? So we will quickly go through the advantages. So high dimensional accuracy is possible when compared to the traditional machining. What are the advantages we have with the NC machine? High dimensional accuracy, because it is controlled by numericals and punched tapes. So it reduces rework and scrap. So great flexibility in operation. So wide variety of programs can be manufactured, which are not possible with an operator. That also we can perform. And machine utilization is as high as 85% to 95% compared to the conventional machining having less than 40%. So therefore, increased rate of production. And complicated profiles can be easily performed and machined. Earlier, because complication, the more complicated and the job will be done in the traditional machining, it depends on the operator. Based on the skill of the operator, only the complexity of the shapes depends. But here, because it is controlled by numerical control, more complicated profiles can be easily programmed and machined. Change in design of workpiece can be easily incorporated as it requires only change in the program. Suppose you want to change something, it can be easily incorporated. Better production control, less requirement of jigs and fixtures, reduced floor space requirement, product development is easier and faster, less skilled operator is sufficient because he need not use his skill, only you have to give instructions and keep quiet. And the machining operation will be done. Only has to see whether it is going according to that or not. The less skilled operator is sufficient, and optimum utilization of the machine. So machine we can use optimally, and reduction of labor cost. Therefore, details about cutting speed, feed, depth of cuts, and dimensions for different operations are stored in the tape. So there is no need how much, what is the speed, what is the feed, and all these things we need not remember. So because it is already stored, automatically it will take from that set of instructions. So these are the advantages of NC machine when compared to traditional machining process. Now, general characteristics of jobs for which NC is most appropriate. For which kind of jobs and numerical control is most appropriate. So greater operator safety. So operator safety is greater operator efficiency. So definitely the involvement of that, the skill of the operator does not depend, because the machine runs based on the program of instructions. So this will reduce the reduction in the scrap, and this will reduce the lead time of production, and it will fewer chances of human error, because it depends when traditional machining is purely depends on the human intervention, that is operator skill. If it is not done properly, if it has done some mistake or human error, then obviously the job will go. That means the quality of the job will be, the efficiency of the product will be reduced. Therefore, there will be fewer. Maximal accuracy and interchangeability of parts is possible. Accuracy can be increased with the help of NC machines. And lower tooling costs, because it increased productivity, and minimal spare parts inventory. So greater machine tool safety and fewer man hours for inspection, and all these things are possible with NC machines. And greater machine utilization, parts are often processed in small and medium sizes. Now, what are the disadvantages of NC machine? So the cost of machine is very high, obviously, when compared to the traditional, because machine control unit will be there, punch tape rates will be there, programming training is required. So though the programming, how to write the programming is very important, and the program for which we have to give some training. So that is the disadvantage. And here skilled labor for manufacturing is not necessary, but the programmer has to be very skilled. So otherwise, if the program is wrong, then the entire operation will go. Therefore, the skilled programmer is required. This is one more advantage. And something went wrong in the control unit or program or feedback channels or servo motors, then its maintenance cost is very high. And high skilled workers are needed, because he should have not only the knowledge of machining, actual machining process, but also he should have a knowledge of machine control unit, tape programming, program language, and all these things. So these are the disadvantages. Now, what are the problems associated with conventional NC machines? Mistakes related with the part programming. So some mistakes, what happens? When the program of instructions related to the particular part to be manufactured were written on the punched tape, the syntax and numerical mistakes are quite common. It is very common. So when we write a program, because the machine has to read that one, that means it will follow the syntax. If there are some numerical or syntax error are there, for example, a semicolon is missing, or some letter is missing, some space is missing, then it will be a syntax or a numerical mistake. The NC tape is not completed correctly in a single pass. Generally, when we prepare an NC tape, in a single pass it can't be prepared. At least 3 passes are required to get the correct program, because we have to check once again, second time, third time, then only the programming, because the programming is very important. If the part program is not done properly, the entire operation, entire manufacturing process will be collapsed. Another major problem with the part programming is achieving the best sequence of steps required for the machining part. So sequence, so which operation has to be done first, second, third, and fourth. That is the sequence of steps. That is very problematic. Non-optimal speeds and feeds. For most economic manufacturing of an object from raw material, it should be given optimum speed and feed during the manufacturing. Therefore, so the speeds and feeds, control of speeds. If a human being is controlling, the operator is controlling, then he will be knowing whether they has to give more speed or less speed, based on the complexity of the shape and the type of material that he is using, both for tool as well as raw material, the workpiece. So here the problem is, in the conventional numerical method does not provide opportunity to change the speeds and feeds during the cutting operations in conventional order. So the program is compelled to set the speeds and feeds. Though the worst case of conditions also, they have to give the whatever the feeded speeds and feeds only should go. He cannot give another speeds and feeds, because whatever is given in the instruction, that has to be followed. Sometimes we have to change the speeds and feeds according to the condition of the material and according to the condition of the operations. So this leads to wastages and low quality of jobs. This also results in manufacturing the jobs at lower than the optimum product, obviously. And punch tapes, the problems related to punch tapes. The punch tape, which is made up of a paper and on which the program is written, is problem itself. So the punch tape then which we are using, if we use a paper, then the paper may be damaged when we use it and all these things. The tape is fragile and susceptible, and therefore it is subjected to wear and tear. So it will have a shorter life. Once the tape is gone, and we have to prepare the tape again. So we cannot reliable on repeated usage. So because it is subjected to wear and tear. So instead of paper, we can use another medium like mylar and all other things. But these materials are quite expensive. Now the problem related to tape reader. Sometimes the tape reader reads the program instructions from the punch tape, but consider it is to be considered a highly unreliable hardware component of NC machine. That tape reader, sometimes it won't read properly. It's a highly unreliable. So if the tape reader won't read it properly, then it cannot give a proper instruction to the machine. Therefore, the major problem with this one. So when the machine break down, the first thing generally maintenance persons will check is whether the tape reader is functioning properly or not. So whenever there is an NC system breakdown is there, first the maintenance people will come and check the tape reader. That means unreliability with the tape reader. Next one is the inflexible controller. The controller is not fully flexible. In conventional machine, the controller unit which is hardwired and making changes the control machine is a tough task. It is not flexible. So we cannot change the control. Once the controller is fixed, and the control will have a limitations of operations. So it is not flexible. We cannot produce whatever we want, because in earlier days, of course, now it is replaced with the computer numerical control. So therefore, it has become more flexible. So these are the problem. The control used in NC machines is the computer, were highly flexible. In CNC machine, as I said, highly flexible as it is. So these are the points about the CNC machines. So hope you enjoyed. So in this session, we have discussed about how these NC machines are introduced. That means the history of the NC machines and what necessitated for the introduction of NC machines. What were the drawbacks in the traditional manufacturing, and what advantage we have these NC machines, and also what are the disadvantages and what are the problems associated with the NC machines we have seen. Most importantly, we have seen various basic components of NC machine, and the functions of each components also elaborately we have discussed. And this topic is very much useful not only for engineering graduates but also for diploma holders. So diploma in mechanical engineering graduates diploma or degree engineering graduates can be benefited with this presentation. So thank you very much for patiently watching this video. And if you like it, please share it with your friends and other colleagues. Thank you.